All right, this one is yet another example of those examination type questions. So here we are. We were given this time a circle. We were told the center of the circle is a 2 and negative 1. We were also given the equation of the tangent, which means we're not going to get those easy marks to get the equation of the tangent. However, we're not told the coordinate b over there. So this is the information that was given to us. So the equation of the tangent is over there. So the first thing you were asked was to determine the equation of the line passing through AB. So look at this line passing through AB. So it's a polite way of asking you to determine the equation of the radius here. So it's the same thing really. If we don't have the equation of the tangent, we normally use the radius to find the gradient of the tangent. The same applies here. We're going to use the equation of the tangent to determine the gradient of the radius. So the main thing being the fact that the tangent and the radius are at 90 degrees to each other. That will be the fact we are going to use and even to abuse. Now looking at this equation, that's the equation of the tangent. Notice in place of m, this is how the general equation of a line looks like. So you can see in place of m there is minus 2. So it's clear to us that the gradient of the tangent this time is equal to minus 2. So what we know, however, is that the gradient of the tangent and the gradient of the radius, their product is negative 1, since these two lines are always perpendicular to each other. So if I put minus 2 here, you can easily get the gradient of the radius to be equal to a half, or just do the negative reciprocal, it's a bit faster. So if we want the equation of this line, we already know that it should be half x plus c. We already know m is a half, so we just need a coordinate which is on this line that we know, and that will be coordinate A. That point A can be used to get this equation going. So I am going to just do this, and I am pretty sure that you are seeing exactly what's happening. Excuse me, I'm going to put minus 1 here in place of y and 2 in place of x, which will give us a c value of negative 2. So as you can see, this one will then be the equation of the line AB as we were asked is the radius. Now the thing is, we now want to determine the coordinates of point B. At this point, we have the equation of the tangent, and now we just finished calculating the equation of the radius. So it's clear to us how point B is a point of intersection of these two lines. So we have this equation right here. I can call it equation 1 right here, and then I can bring that one over here and say minus 2x plus 13, that will be our equation 2. If we want to solve these things simultaneously, we can do so. It's easy to do. So I am going to just say a half x minus 2. Since y is equal to y, let's just equate the two equations. Half x minus 2 is going to be equal to minus 2x plus 13. This is child's play for everyone, so I'm not going to take too long. Half plus 2, that should be 5 over 2, and 13 plus 2 would be 15. If you divide by 5 both sides, there will be a 3 here, which means x itself is going to be 6. So the x value for B is going to be 6 over there. Let's see what y would be. So since B is a point of intersection of these two lines, it doesn't matter which one I use. So I think I am going to be tempted to use this one, which says minus 2x plus 13, since it doesn't have fractions on it. So we put a 6 there, and is that a 13? Let's see. So it does look like it's minus 12 plus 13. It should then be 1, as far as I can see. So that should be 1 over there. So that is another thing that you were asked, so make it a point that you understand that. And then the next question was for you to determine the equation of circle A in the form x minus a squared plus y minus b squared is equal to r squared. Now we want the equation of this circle. We have everything that we need. So getting the equation of that circle is really not going to be a problem at all. So from what we know, it's actually number 3 we want. We were told to find the equation of the circle like this is equal to r squared. We need to find a, b, and r. The center of the circle is now available. It has been for a very long time. So it's here, and then I'm going to say y plus 1 and say r squared. The thing is, you want the radius of this. You can use distance formula using these 2 coordinates and calculate the radius, and then you carry on. But I always say to you, there is no need for you to start up another distance formula when we know that this whole formula actually came from the distance formula. You can come and substitute any point on the circumference of this circle. In this equation, you can easily get r squared. What I'm saying is, if I take, for example, this b, you can see at x, I'm substituting 6 like this. If I do stuff like this, that is faster according to me. And then this is r squared. You can easily get your r squared now by saying this is 4 squared 16, 2 squared 4, that should be 20. So the equation of this circle can easily be written as x minus 2 squared plus y plus 1 squared is equal to 20. We don't want the radius, we want the radius squared. So there it is. Well, the last question for this one is the main reason I took this question and I wanted to discuss this question with you. We now have a situation of circles that are touching or intersecting. So let me first of all mention the question. The question said there is another circle with this equation. X squared minus 16x plus y squared minus 4y, like this. And you also to notice it is equal to negative 63. So this is the circle that we were told. We're told there is yet another circle here. So the circle is drawn on the same set of x's. Now we are required to show with necessary calculations that the 2 circles touch externally. So this circle here and that circle there, if I draw them on the same set of x's, we are actually expected to show that they touch externally. Well, I'm not going to draw it here because nothing was drawn to scale so far. So we are going to use our method that we discussed the previous lesson on showing how 2 circles, remember what we said, if 2 circles are touching externally here, we said this was A, this was B. We say the distance AB is definitely just going to be equal to R1 plus R2. So we are simply going to put R1 here and R2 like this. So this is what we are going to do. Okay, let us quickly do that instead and see how far we can go with that. So let's go. If you look at this, let's get the center of this circle first. So it's going to be, if I do what you already know, then I put negative 63 over there. Remember, we are to get the third term on both of them, and it is b over 2 squared. So if I say b over 2 squared, notice it's minus 16 over 2 squared, that should give us 64, and that should give us 64 over there. And then minus 2 over 2, that would be minus 4 over 2 would be negative 2, so we add 4 and we add 4 to the other side. So you need the center and the radius of this circle for you to use the formula that we mentioned. So I am going to do this. you know that's the b over 2 step. And then this side, you can see how it is simply going to be equal to 5. So the center of the other circle, you can see how it is 8 and 2. That's the center. This center, let me call it B. Don't think of it as B of that one. So it will be at 8 and 2. From our lesson, the first center we called it A, and the second center we called it B. So the first center that we already know is actually 2 and minus 1. Those are the things we want to compare. Let's see, the radius of this circle here, which I'm going to call R2, is root 5. And the radius of this circle, which I'm going to call R1, we proved it at one point to be equal to root of 20. Root of 20 can easily be seen as 4 times 5 here, that will be 2 root 5. Okay, now that we have everything that we need, here is what I said we must do. I hope you remember. You first of all calculate distance AB. Notice AB as x2 minus x1 squared. The AB should be the distance between the two centers of the circle. So, like that. So AB is going to be, you've got your 8 there. So it's 8 minus 2 squared. And then you have 2 minus 1. I'm just going to write it as plus 1 squared. So I think the distance AB is going to be easy to see. This one happens to be 36 plus, that would be 9. I wonder what that is. So why don't I rather use my calculator instead? That would be easy to do. Let us see. Okay, so that will be 45, which is simply going to be 3 root 5 if I change it. So that would be the distance AB for this question. And then you have to find R1 plus R2. Those are the things you need. So now that you have distance AB, the only thing you have to find is R1 plus R2. So if you remember, R1 is root 5 and R2 is 2 root 5. And it is 3 root 5. Now we noticed how AB, the distance between the two centers, happens to be exactly equal to R1 and R2. So you can say, therefore, the circles touch externally. They just touch. They touch only externally. So make sure that if you didn't quite grasp this one, go to the lesson where I explained these concepts very well. So make sure you grasp this. I think it's a good question for you for practice. Good.